Today in this video we will start the class 9 maths, that is the chapter 1 number system. So this number system is mainly classified into two types. One is rational numbers and another one is irrational numbers. So under the rational numbers we get natural numbers, whole numbers, integers, decimals and fractions. So we will discuss further what are natural numbers, whole numbers, integers, decimal, fraction, what are rational number, irrational number. So this is the main classification. The number system can be classified into two types, rational number and the irrational number. Again, this natural number, whole number, integers, decimal, fraction, all together they will constitute our rational numbers. This number system can also be called as the real numbers. So real numbers consist of rational number as well as irrational numbers. Now let's discuss one by one what are natural numbers, whole numbers, integers, decimals and fractions. Now first, natural numbers. It is denoted by capital N. So natural numbers means all the counting numbers are called natural numbers. Whenever we start the counting, how we count? We start counting with 1, 2, 3 like this, isn't it? So all the counting numbers starting from 1 are called natural numbers. So what will be the definition of natural numbers? All the counting numbers starting from 1 are called natural numbers. So 1, 2, 3 like this till infinity, all are called natural numbers. So all the counting numbers are called natural numbers. Then our next type of number is called the whole numbers. Whole numbers. So whole numbers means what? Natural numbers along with the zero are called whole numbers. So natural number 0 plus natural numbers are called whole numbers. So natural number means what? The number starting from the 0, 1, 2, 3 till infinity are called the whole numbers. So see, now why it is called the whole number? So when the 0 was invented, and we feel proud that the 0 is invented by our Indian mathematician. All of us we know na the Aryabhatta invented the 0. So when the 0 was invented, it makes our whole number system complete. That is why it is called the whole number. For example, if we want to represent anything which is null or nothing, so there should be any number which can represent the nothing. So the 0 will complete our number system. That is why it is called the whole numbers. So what are whole numbers? 0 plus all the natural numbers are called whole numbers. Starting from 0, 1, 2 till infinity are called whole numbers. Then the next type of number are called integers. Integers. It is denoted by Z. Now, let's suppose if I draw a number line, So center will be 0. Right side plus 1, plus 2, plus 3, plus 4, like this. Left side will be minus 1, minus 2, minus 3, like this. So what are integers? So in this number line, whatever number I have written here, all these constitute our integers. So how can we define the integers? All the positive natural number, all the negative natural number, including 0, are called integers. All positive natural numbers, all negative natural numbers, and 0. So these are positive natural number, these are negative natural number, including 0, are called integers. So now if I ask you whether 0 is positive or the negative, so always remember 0 is neither positive nor negative, it is a neutral number. So integers means what? All positive natural number, negative natural number, including 0, are called integers. Now next type of number will be rational numbers. Rational numbers. So the definition of rational number, it is given in the book like this. Any number which can be written in the form P by Q, where P and Q are integers, where P and Q are integers, and this Q should not be equal to 0. So any number which can be written in the form of P by Q. P by Q is nothing, it is, we can say, the numerator by denominator form. Any number which can be written in the form of fraction are called the rational numbers. One condition is there, this P and Q has to be integers. Just now we have studied what are integers. All the positive natural number, negative natural number, including 0, are called integers. But one condition is there, this Q, or we can say this denominator, should not be equal to 0. For example, if I write 2 divided by 0, then this is not a rational number, because always remember in maths, writing 0 in the denominator, it is not permissible. But if I write 0, 0 is a rational number, because 0 can be written how? 0 can be written 0 by 2, 0 by 1, 0 by 5. Okay, so remember, all our natural number, all our whole number, all our integers are example of rational numbers. For example, if I write minus 2, it is also a rational number. Why? Because it can be written in the form of P by Q. We can write minus 2 by 1. Okay, for example, 3, it is also a rational number, because it also can be written 3 by 1. So all our whole numbers, whole numbers, natural numbers, integers, all these together, they will constitute our rational numbers. So remember, just remember, rational number means any number which can be written in the form of numerator by denominator form. Only one condition is there, the denominator should not be equal to 0. Then next, irrational numbers. Irrational numbers. Irrational number means any number which cannot be written in the form P by Q, where P and Q are integers and Q should not be equal to 0. Means rational number we have studied any number which can be written in the form of P by Q. But irrational number means what? Just opposite. Any number which cannot be written in the form of P by Q. So example of some irrational number, remember all the imperfect square root are the example of irrational number. For example, if I write root 2, root 3, root 5, root 7, these are all example of the irrational number. As well as pi. The pi also is an example of irrational number. Now, to understand the irrational number more nicely, we should know the decimal expansion of the numbers. So, we will learn the real numbers and their decimal expansion. What are the different types of decimal expansion? For example, see, if I divide one number, 12 divided by, let's suppose 3. So 3 4s are 12. So remainder is 0. Now let's suppose if I divide another number, 10 divided by 3. So what I will get? 3 3s are 9. 1. Decimal point 0. 3 3s are 9. 1. Again 0. 3 3s are 9. So I will get the decimal expansion, which will be after decimal point the digits will be keep on repeating. Now let's suppose if I divide 102 divided by 5. So 5 20s are is 100, isn't it? Now 2 decimal point 0. 5 4s are is 20. Now here I have done the three types of division. Here I got the remainder 0. Here I got after decimal point the digits will be keep on repeating. I will never get the remainder 0. In this case also I got the remainder 0, and after decimal point the digit terminates. Now this type of decimal expansion where after decimal point the digits will be repeating. Here you see 3 point, if I keep on dividing I will be getting 3.33333 like this. So this kind of decimal expansion it is called non-terminating repeating decimal expansion. This kind of decimal expansion is called non-terminating but repeating or recurring decimal expansion. Why it is called non-terminating? Because the digits will not terminate after decimal point. That is why it is called non-terminating. And why it is called repeating? Because some of the digit or sometimes some set of the digits will be repeating. But in this case we got after decimal point the digit got terminated. So this kind of decimal expansion is called terminating decimal expansion. So here I got non-terminating repeating decimal expansion, and this is an example of terminating decimal expansion. Okay, so whenever any number is divided by another number, all the rational numbers, the decimal expansion of the rational number will be either terminating decimal expansion, or if it is not terminating, then the decimal expansion will be non-terminating repeating. So remember, by looking at the decimal point also we can say whether our number is rational or irrational number. For example, if we get the decimal expansion like this, 3.333 so this one can be written like this, 3.3 bar. That means what? These three digits will be repeating. So if the decimal expansion is non-terminating but repeating, it is an example of rational number. Or for example, this is the decimal expansion 20.4. This kind of decimal expansion it is called terminating decimal expansion. So terminating decimal expansion also example of the rational numbers. Now for example, if I write the decimal expansion like this, 2.121212 ... Here what I can say, this number, these two numbers 1 and 2 keep on repeating. So this one I can write 2.12 bar. So above both the 1 and 2 I have to put bar, because here not the single digit is repeating, both the digits are repeating, that is 1 2 1 2 1 2. So this kind of decimal expansion also called non-terminating repeating decimal expansion. But if I write the decimal expansion like this, 3.1412902356901, here you see this kind of decimal expansion, it is called non-terminating non-repeating or recurring. Here you see the decimal point, after decimal point the digits will never terminate, as well as there is no repetition of the digits. So this kind of decimal expansion, it is called non-terminating non-repeating. And if the decimal expansion is non-terminating non-repeating, this is an example of irrational. So that is why all our imperfect square root, for example root 2, root 3, root 5, if we calculate the values of root 2, root 3, root 5, all the imperfect square root values if we calculate, then we will find that the decimal expansion will be non-terminating as well as non-repeating. That is why these imperfect square roots are the example of irrational number. As well as if we calculate the value of the pi also, we will find the decimal expansion of the pi also non-terminating non-repeating. So what we can summarize from the decimal expansion? So decimal expansions are of 3 types. What are these? Decimal expansion, it can be either terminating or it can be either non-terminating but repeating. So if the decimal expansion is terminating or non-terminating but repeating, then this is the example of rational number. Whereas if the decimal expansion is non-terminating as well as non-repeating, then this kind of decimal expansion is an example of irrational number. So by looking at the decimal expansion also, we can say whether our number is rational number or irrational number. So if our decimal expansion belongs to these two categories, then our number will be rational number. If it is non-terminating, non-repeating, then it will be irrational number.